Welcome students to Secondary Math 1A. We're going to start with Unit 1, Lesson 1, which is expressions and formulas. So for this course, you won't ever have to define any of the words, but you need to understand when we say them what we are talking about. So my definitions are not going to be textbook definitions. It's going to be more understandable for students. So terms are separated by a plus or a minus. Okay, so a term can have a couple of letters together, they can have numbers together, but you want to count how many different objects or terms are between the pluses and the minuses. So coefficients, those are going to be the numbers that are in front of a variable, which remember a variable is a letter. Okay, the base is going to be it's going to be a number or a letter, and you will see it written with an exponent, which is a superscript. So I call it on bottom. So like you might see something like y squared, so y is the base, or you might see 5 cubed. 5 is the base. So it could be a number or a letter, and I say it's written on the bottom. The exponent is, if you're in Word, it is the superscript, but it is usually the little number or combination. It can be letters as well, that is written smaller with a base value. It's written with a base. So our exponent would be 3, and the exponent here would be 2. The constant, it is just a numerical, which means number, term. So 5 squared, that whole thing is a constant. I could also write it as 25. That is a constant. There will be no letters associated if it's constant. Okay, so let's look at our first example. They give us 6x plus 7y squared minus 1/2 minus 17x to the 4th. So the first thing is they want to know how many terms are there. So we go to the pluses and the minuses, and I see this is one term, that 7y squared is all another term. Then I have 1/2, and then I have 17x to the 4th. So we actually have 4 separate terms. For coefficients, we're going to look in front of all of the letters. So I look in front of, here's x, so the coefficient would be 6. Here's y squared, we look in front, the coefficient is 7. I don't have a letter here. And then here's x to the 4, so look in front, and it's actually negative 17. Remember, negative and subtract have the same meaning. The base number, I want to look for powers. So I see a squared, so the base is the y. It'll be touching. And then here's an exponent, so its base is x. Exponents we just found. Here's my little superscript of 2, and here's my superscript of 4. And then constants don't have any letters, so I can't have 6x, I can't have the 7y squared, but this one was just a number, and you always want to take the sign in front. And then our last term had a letter with it. Okay? All right, so example 2, there's going to be tons of right answers. So first thing I want to do is it says write an expression that has 3 terms. So I'm going to leave little blanks. And I know between them I can put a plus or a minus, but let's see if we have any other requirements. So that one's done. I want the highest exponent to be 4, so I'm going to make something x to the 4th. And then I just got to remember everything else needs to be lower. A term that has a base of 5, well, I can make this like 5, and as long as I have it smaller, and then no constant terms. So that means they all need letters. So I'm going to go back. If I have a term that has a base of 5. So since I have 5 squared, I still have my base, but I can't just leave it as a 2, so I'm just going to put a letter there. And then I need another term, and I know it needs to have a letter, so I'm just going to make this, how about 8, and I'm totally just going to make this up, a y. So I've got plus, and I'll just make one minus. But there is such a variety of answers that you could have, so just go through the requirements. All right, for the last types of problems, they're going to give you a given equation, tell you what it means, and then they're going to ask you questions about it. So for example 3, for babysitting, Daisy charges a flat fee of $5 and then $4 each hour. So you can see that, here's my $4 and here's my 5. This can be modeled by the equation C equals 4H plus 5. So what does the C stand for? So you have to kind of look at the context clues and you say, oh, well, C would be the total amount of money that she would make babysitting. And you could say Daisy made babysitting. Just get the idea that it's a total amount of money. The 5, well, what does the 5 represent? Well, the 5 represents the flat fee that she charged. Flat fee. $5 charged. And use your own words. And the H, well, we don't have anything with H, so we have to think. If it's for H, H is for each hour. So it's the number of hours that she's going to babysit. So I can leave it as number of hours, or I could say that she babysits and get a little bit more specific. All right, let's look at the last example. When you jog, you can burn 450 calories each hour. This situation can be modeled by T equals 450C. So what would T represent? Well, T stands for your total number of calories burned. What does the 450 represent? Well, that represents the number of calories burned each hour. And then what does the C represent? Well, C would be the number of hours that you jog.